Hello everyone, welcome to this video number 2 on analytical simplification. So this is unit 6 of computer methods in power system for BTech. Now in this video we shall go to this question, that is analyzing of single line ground fault using two component method. So in back unit uh, somewhere we have learned single line to ground fault using three components, but now we want to do it by two component method. So what is this two component method? Is that what exactly we are doing here? uh, okay, so now already in previous video we learned that what is two component. In two component we have two networks. One is zero sequence network and one more is positive sum network and positive difference network. And these two networks, they are identical, we have seen. As far as their as passive network, they are identical. Only the difference is that voltage and current, they are different. Now these two networks, so zero sequence network and positive sum or positive difference between, how they are connected for this single line to ground fault, that is what we want to investigate. In the three component method we have seen that the positive, negative and zero, they are all connected in series. They are all connected in series. But now we want to investigate for two component theory, that is these two networks, how they are connected. Okay, so let us start with this. Consider a single line fault on phase A as shown. So this is the three lines shown, A, B and C, and we are assuming that a single line to ground fault is happened on phase A, and these are the resulting voltages. So VA is the voltage of line A with respect to ground, VB is the voltage of B phase with respect to ground, and C phase with respect to ground. And these are the fault currents. Let IA be the fault current through this fault impedance. And because now here the constraint, here we get IB is equal to 0 and IC is equal to 0, there will not be any flow of current in B and C phase. And now let us write the constraint or the boundary conditions. Now the boundary conditions, here it is written that IB is equal to IC is equal to 0, there is no current in these two phase, and VA, that is the voltage of phase A with respect to ground, it is equal to ZF into I. So this is our voltage what we get. Here it is VA. Now based on these constraints or the boundary conditions, we have to derive how these networks are connected. Positive, the zero, positive sum and positive difference. How these equations, they are connected. So let us start finding out that. So now using the similar equations in the previous video, I have given the two component model, that is VABC equal to B into V naught summation delta. Now this equation, don't write this equation in the exam. Now we have to write this equation, current equation. It is similar, but only I am converting this voltage to current equations. B into I naught summation delta. So using the following equation, so this equation we have to write. This is the two component model. Okay. Now using this equation in the previous video, please check out what is this equation we have. And from this equation, we get this now. So IB is equal to, we get IB is equal to H, or as I told already, you can take it as 1 IA naught minus 1 by 2H IA summation, like this. So if you want, I will write this equation here. So it is IA IB IC, it is equal to The B matrix is that, please verify this B matrix. I think it is 1, 1, 1, 1, and 1, it is minus half, and here minus j root 3 by 2, and here it is 1 minus half j root 3 by 2, and here we will have this IA not summation delta. So it is IA not, then IA summation. This is, and this is IA delta. So now here we are writing equation for IB and IC. So here we get this IB equation, IB equal to 1 into IA naught. So IA naught we have here. So as I told here, it is taken 1 by H, but why H we are taking it as 1. Okay. So you will get this IB equation, and then we get this IC equation. Now, if you add these two equations, IB plus IC, okay, H we are taking it as 1, as I already told. Adding these equations, we get, now we can see if you add these two equations, then this is not there. So it is 2IA naught, here it is there, and here it is, these two are also added. So 1 by half H is not there, half half it becomes 1, and we get this IA summation, and this IA delta it will get cancelled because positive and negative. So we get this one equation. Okay. Now what this equation says clearly, that positive, we can look at this equation, IA naught means 0, and I summation is positive sum network, and they are equal. They are equal in the sense what they are connected in series. So one indication is here, positive and positive sum and zero sequence network, they are connected in series. Then if you subtract these two equations, IB minus IC, if you do, then we get, we can see here, we get IA delta is equal to 0. IA delta equal to 0. What it indicates, that the positive difference equation, it is not existing. It is not existing. So these two equations gives us the idea that positive and 0, they are connected in series, and there is no positive difference equation. So here we can okay, so here we can see this. Now let us go to another equation. We know that VA is equal to Z of I. Now this part is repeated here, kindly. This part, it is repeated in the previous slide, kindly neglect this. Okay, now one more equation we have here, but VA is equal to ZF into I, so we can write. So what is VA? VA we can write it as VA naught plus VA1 plus VA2. Okay, equal to ZF, and IA is equal to IA naught plus IA1 plus IA2. Now what further we can write? Now if you substitute for IA naught, if substitute for IA naught is equal to, from this equation, IA naught is equal to IA summation divided by 2. If you substitute here, and this it is written as VA summation, VA1 plus VA2 is written as VA summation, VA naught is taken as it is, and ZF is there, IA naught, and this is now 2 IA naught, this is 2 IA naught, so it totally becomes 3, it is written in terms of summation. Okay, so okay, so it becomes 3 I naught, 3 I naught, but I naught, it is equal to I summation by 2, so it is 3 by 2 I summation. So we will get this equation here. Now what implies this equation? It implies that positive sequence and positive sum, they are connected in series, and their addition of voltage is equal to 3 by 2 Z of I summation. So this all equations. So above equations, what they imply is that interconnection of sequence. Negative network and positive sum, they are connected in series as already told, and positive difference network, they are not existing, is not existing. So I have written not existing. Okay. So here it is written positive difference equation I not is equal to 0. This should not be considered for the purpose of analyzing. Only we have to consider this zero sequence network and the positive sum network. They are connected in series for the purpose of analysis. Now from the figure we can calculate this IA naught current as this equation. IA naught is equal to HVF divided by Z naught by 2, the negative sequence. So this modification is done in order to make IA naught equal to this 2 IA naught. In order to make this equality, there is some changes in the impedances we can find here. Zero sequence network is divided by 2 and the fault impedance is made 3ZF by 2. So this modification is only done to obtain this IA summation is equal to 2 IA naught. So 2 IA naught we can find it by this equation, the voltage divided by the total impedance. So the total impedance is there in the denominator and then we can find this I naught. Once we get I naught, from previous equation we have seen 2 I naught is equal to I summation, and we can, and I delta is equal to 0. So from these two equations we can find what is I. Okay, uh, now once we get this IA naught and IA summation and IA delta, we can find IA, IB, IC from the two component model. So this is how we can analyze single line to ground fault using two component method. So in this video up to this only, we'll continue in the next video. Thank you.